Assalamu alaikum. Today we will discuss question number 10 from the normal distribution. It is stated tea is sold in packages marked 750 grams. Whenever we are going to purchase the tea packets, there is weight mentioned on the packet and its weight is 750 grams, but actually it is not 750 grams. Sometimes it is more than 750 grams and sometimes it is less than 750 grams. To ensure that the packet is 750 grams, company fills the packet more than 750 grams so that the packet must have 750 grams. यानी एक्चुअल में 750 ग्राम्स उसमें लिखा हुआ है पर वो होता नहीं है. कंपनी इंश्योर करने के लिए कि 750 ग्राम्स ही उसमें है, उसको थोड़ा सा ज़्यादा फिल करती है. फॉर एग्जांपल 760, 770, 780, इट डिपेंड्स ऑन द कंपनी. तो इस केस में कंपनी ने 750 को इंश्योर करने के लिए थोड़ा सा ज़्यादा ही फिल किया है. The masses of packages are normally distributed with mean 760 grams. So the weight of the packages is actually 760 grams. So mu is written here 760 grams, and standard deviation, which is unknown. That's why sigma is equal to question mark. What is the maximum value of sigma if less than 1% of the packages are underweight? If we are talking about underweight, it means the weight is less than 750 because on the packet 750 grams is mentioned. So underweights are those packets who are actually does not have the weight 750 grams. वही अंडरवेट होंगे जिनका वेट जो है वो 750 ग्राम से लेस होगा. तो हम फिगर में क्या करेंगे, 750 से जो लेस का एरिया है उसको शेड करेंगे एंड इट इज 1%, लेस देन 1%, यानी इससे भी 1% से भी लेस हो. So the mean of the distribution is 760 and the area below the 750 grams is 1%, which is equal to 0.01. So we want to find the shaded area involving 750 grams is equal to 0.01. But 750 grams is first converted into the z-score. So parallel is a z number line, and corresponding value on the z line is first obtained, and this is here 7650 minus 760 over sigma. This is the value of z-score, and this z-score is minus 10 by sigma. Since sigma is unknown, so sigma is written as it is. So now we can find the probability x less than 750. The shaded area denoted by the pink color is now converted into the z statistic. You can see the z value is z less than minus 10 by sigma, and this area is given as, from the figure you can understand that this area is 1%. So in this equation we can write it as 0.01, and phi of minus 10 by sigma can be written in place of probability z less than minus 10 by sigma, and phi is equal to 0.01. Phi will come on the right side of the equation. Whenever phi comes on the right side of the equation, we have to write it as phi inverse of 0.01. From the table we can see that the value at 0.01 under the column 0.000, its value is minus 2.3263. So we will write this value in our equation and obtain the value of sigma. So we solve it. Sigma is equal to minus 10 by minus 2.3263, and this gives us 4.299 grams. Since the weight is given in grams. So mu is in grams, x is in grams, and the value of standard deviation is also in grams. Next, 10b. Suppose that the life in hours of an electric tube manufactured by a certain process is normally distributed. So we can observe that the normally distributed x is normally distributed, and with parameter mu is equal to 160, unit of measurement is hours, and sigma is unknown. So sigma hours. What is the maximum allowable value of sigma if the life x of the tube is to have probability 0.8 of being between 120 and 200 hours? So between 2 points 120 and 200, from the figure you can see that mean is 160, so it is in the center of the figure, and 120 is definitely less than 160, so it must be on the left side of 160, and 200 is more than 160, so it should be on the right tail. And between these 2 points 120 to 200, probability is given as 0.8. This one, the probability 0.8 between 120 and 200 hours. In the total area under this curve from minus infinity to plus infinity is always equal to 1. Whenever 0.8 is subtracted from 1, then the 0.2 is the remaining area which lies on the tails, both tails. The sum of the area of both tails is 0.2. If we can observe that 160 minus 120, the difference is 40. 200 minus 60, difference is 40. So both points are equidistant from the center. If both points are equidistant from the center, then the remaining area on the tails are also equal. So half of the point 2 is on the left tail and half of the point 2 is on the right tail. So the distribution of probability is 0.1, 0.8, and again 0.1, and sum up is 1. First we find the z-scores on 120 and 200. So now we can find the z-scores on 120 and 200. At x is equal to 120, z-score is obtained by x minus mu over sigma, which is minus 40 by sigma, and corresponding values of 200, the z-score is 200 minus 160 by sigma, which is 40 by sigma. So using these two values, we can write our probability first in terms of x, which is probability x lies between 120 and 200, this one, and convert it into the z probability minus 40 by sigma to z up to 40 by sigma, and this probability from the figure you can understand it is given as 0.8. So we write it here 0.8, and we know that the point 120 is here, and below this point the area is 0.1. So we can write here phi of minus 40 by sigma. It means the area starting from minus infinity up to this point 120, and into the z-score its value is minus 40 by sigma. So phi of minus 40 by sigma is 0.1. And here phi inverse of 0.1 is obtained by the table 10a. The quantiles of the standard normal distribution under the column probability, we can obtain the value of phi inverse of p. P is 0.1. So corresponding value under the column 0 is minus 1.2816. So we use this value in our solution, minus 1.2816. And using this value, we can find the value of sigma. So sigma is obtained as sigma is equal to minus 40 divided by minus 1.2816. So solve this equation here, and the result is 31.21. Sigma is 31.21. The values are given in terms of what is the unit of measurement in the statement? Hours. So we will write here 31.21 hours. This was the question number 10. Now we will discuss question number 12 here. This is question number 12. It is stated in a normal distribution 31% of the items are under 45 and 8% are over 64. Find the mean and standard deviation of the distribution. First, we plot both of these areas in two figures. First one, 31% of items are under 45. So in the figure, 45 is on the left tail because only 31% area below this point, under this point. So 31 is converted into 0.31 and this shaded area is on the left tail. So 45 must be below mu, and the other is 8% are over 64. So in another figure we can write it as 64 is on the right tail because only 8% area is above this point. So 0.08 is written on the right tail, and from these two equations probability x less than 45 is equal to 0.31 and probability x greater than 64 is equal to 0.08. We have two equations and we are going to find two unknown values of the parameters mu and sigma. So we can solve these two equations simultaneously to obtain the unknown values of the parameters. First, we consider probability x less than 45 is equal to 0.31. X is converted into the z-score and 45 is converted into the z-statistic. 45 minus mu over sigma is equal to 0.31, and probability z less than is now written in form of phi. So phi of z-score 45 minus mu over sigma is 0.31, and this value is obtained from the phi inverse table of quantiles of the standard normal distribution, table number 10a. So using this table, this one, 0.31 is searched under the probability column P. It's not here. 0.31, this one. 0.31 is under the column 0. Its value is minus 0.4958. So we use this value in our expression, and our equation is now converted into 45 minus mu is equal to minus 0.4958 into sigma. This is our first equation, which is obtained using the first figure and first given probability. Now using the second figure and second probability, probability x greater than 64 is equal to 8%. We can write this other equation. So probability x greater than 64 is given as 0.08. First, we convert x greater than 64 into in terms of x less than 64 by subtracting 1 minus probability x less than 64 is equal to probability x greater than 64 is equal to 8%, and then x is normally distributed and converted into the z-score. So its z-score is 64 minus mu over sigma. And the next step, one will come on the right hand side. So the result is 0.92, and probability z less than is written in terms of capital phi of z-score. 64 minus mu over sigma is equal to 0.92, and phi inverse of 0.92 from the table. Next, this is 0.92. So 0.92 under the column 0, its value is 1.4051. So substituting this value here, 1.4051, our second equation is 64 minus mu is equal to 1.4051 sigma. So solving these two equations first and second simultaneously, we can have the value of mu and sigma. We can subtract second from first or first from second anyway. Left hand side is subtracted from left hand side and right hand side is subtracted from right hand side. Sigma is taken as common and mu will be cancelled out from the left hand side. So then the result is sigma is equal to 10. Once sigma is obtained, we can substitute its value in equation 1 or 2 and get the value of the parameter mu. So we are substituting this in equation 2. 64 minus mu is equal to 1.4051 into sigma, and sigma is replaced here 10. And for solving this equation, we will have mu as 50. Now consider the question 12b. If x is normally distributed with mean, mu and variance sigma square, and the probability x less than 35 is zero point 0.2, and between these 2 points probability is 0.65, find mu and sigma. So x 35, x less than 35, so probability less than 35 is on the left tail, which is shaded by the pink color, is 0.2. So we wrote here in the shaded area the probability is 0.2, and this shaded area is below the 35 point on the left tail. So from the solution, probability x less than 35 is 0.2. And the second condition which is given here is the probability between these 2 points 35 to 45 is 0.65. So we construct one more figure. The point 35 and 45 are plotted and mu is in between. Because 0.65 is more than 0.5, it means one point should be on the left tail and other point should be on the left tail, right tail. 35 is plotted on the left tail and 45 is plotted on the right tail, since the probability is greater than 0.5. Mu is in the center. In the first figure, we can observe the probability less than 35 is 0.2. So we can also write here the left tail shaded, unshaded area is given as 0.2. And the total area under the point 45, this is 45, and the point starting from minus infinity to 35 it's 0.2, and 35 to 45 it's 0.65, and altogether its value is 0.85, and total area under the curve is 1. Then remaining is on the right tail, which is 0.15, which is not actually required. Probability x less than 35 is 0.2, convert it into the z-score, and z-score probability z less than can be written in the form of phi. Phi of z-score is equal to 0.2, and next we can convert phi z-score is equal to phi inverse of 0.2, and using the table we can observe that 0.2 is this is table 10a, quantiles of the standard normal distribution. Under the column P, we will search the value of probability, which is 0.2. Under the column 0, its value is minus 0.8416. So considering this value, we can observe that the first equation is 35 minus mu is equal to 0. Minus 0.8416 sigma. This is first equation. And probability x between 35 and 45 is given as 0.65. So using this condition, we can write by the theorem phi of b minus phi of a, its value is phi of 45 minus mu over sigma, and phi of 35 minus mu over sigma, and its value is 0.65. Now substituting the probability from first equation, which is given phi of 35 minus mu over sigma is 0.2, so its value is written here, phi of 35 minus mu over sigma. By substituting this value, we can have the probability 0.85. So phi will be coming on the right hand side, phi inverse of 0.85, and its value from the table is obtained 0.85, which is on the third page. This is 0.85. Under the column 0, its value is 1.0364. So 1.0364 is incorporated in this equation, and this is our second equation. 45 minus mu is equal to 1.0364 sigma. So using these two equations, equation number 2 and 1, we can solve them simultaneously or by substitution method to obtain the value of sigma and mu. So from these two equations, we will have sigma as 5.32, and putting this value in equation 1 or 2, in our case, we are substituting it in 1, and the value of mu is obtained as 39.48. Since there is no unit of measurement, so answer is 39.48 of the mu and 5.32 of the sigma. Thank you so much for watching this video. Allah Hafiz.